And so what you want to do is when you first, so this is the Vlab.exe interface. You'll need to load the correct workbench. So what you'll do is you'll go to File. We're going to go to Load Homework. And the homework we want to do is under the molarity and density folder. And we're going to click on Dilution Problem 2. That's where we're going to have all our chemicals for us to use. So again, I went File, Load Experiment. We're going to do Dilution Problem number 2. And so once you'll do that, if you click on the stock room, you see you have a list of chemicals to use. And so for me, for this exercise today, I'm going to use the 15 molar perchloric acid solution to kind of show you how to go through and do the experiment. Now, one thing you need to do is under Tools, where it says Transfer Bar, we're going to put Realistic Transfer. So you go to Tools, Transfer Bar, Realistic Transfer, and that way it's more like how you would do it in the real lab. And so the first thing we want to do is prepare a 50% solution of our perchloric acid. So if you double click on the perchloric acid, it puts a bottle of it on the lab bench. And you can kind of think of this perchloric acid as 100% solution. So if I rename it, it'll be 100%. That's like our stock solution. So we're starting with 100% perchloric acid. We want to prepare a 50% solution. So to prepare a 50% solution, we got to use that equation C1V1 equals C2V2. And we want to prepare 100 milliliters of this solution. So C1 is 100%. V1 is what we're looking for. C2 is 50%. And V2 is 100 milliliters. So now when we set this up, so you'll notice here V1 is 50 milliliters. So in order to make a 50% solution, we're going to need 50 milliliters of the 100% solution. And then we're going to need 50 milliliters of DI water. So if you click on the water tank here, it puts water up there as well. So we have our water, we have our perchloric acid. We need 50 milliliters of the 100% perchloric acid solution, and we need 50 milliliters of the DI water. So now we need some glassware. So on here where it says Workbench, if we go to where it looks like an Erlenmeyer flask, a beaker, and a volumetric flask, you click on that. Now you get a selection of different types of glassware we're going to use. So one thing we need is a beaker. So we're going to select a 250 ml beaker. We also need a graduated cylinder. And since we need 50 milliliters of the 100% solution, we're going to use a 50 ml graduated cylinder. And to make our solution, we're going to use a 100 milliliter volumetric flask. Now we may need a few more pieces of glassware as we get going, but this is good enough to get us started in the right direction. So what I'm going to do is I'm going to measure 50 milliliters of the 100% solution. But you can't just, if you try to pour it directly into the graduated cylinder, it's very hard because it's not a very precise piece of glassware, so it's very quick when you pour it. So I'm going to pour it first. I'm going to pour some into a beaker. And you'll notice down here it says the pour button, and you see we have this little bar. It goes 0, 500, 1,000, 1,500, 2,000. So as you pour, it shows you how much you're pouring into the beaker. So when I click pour, just by that quick of a touch of a button, we've added this much solution to it. Which is, if you look up here in the top right corner, it says in the 250 ml beaker, we just added 193.2 milliliters. Because again, the jug is not very accurate, so it's very quick in pouring. So that's why you want to pour it into a beaker first, and then pour it into a graduated cylinder. Now here you'll see for the beaker, it's a little bit more accurate. We have 50, 100, 150, 200, 250. So we want to hit the pour button as close as we can to the 50 mark. And then when we get to the 50 mark, I'll show you a little trick we can do to get right on 50. So I'm going to hold pour. And it's kind of quick, so you got to be quick to do it. Now, if this time, at this part, if you go over, it's okay. We can take some out. Whew. So I got very close to 50. And again, if you click on the glassware and check in the top right-hand corner, it says currently we have 49.18 milliliters in the graduated cylinder. So in order to get that last bit of solution into my graduated cylinder, I'm going to go back to the glasswares, and I'm going to select a 5 ml pipette. And the reason I'm selecting a 5 ml pipette is because it's a very precise piece of glassware, and it's very slow at delivering the volume. So you can do very small bits at a time. And so I'm just going to go to my beaker. So when you bring it and you see the green target, it's ready. Let go of your mouse button. And we're going to withdraw. And notice here the measuring goes from 0.02 to 5. So it's a very slow than the beaker, slower than the beaker. So now I've filled up my pipette. It doesn't have to be completely filled because we only need to add about 0.9 milliliters. So now I'm ready to pour. And so we don't want to pour too much. We want to get right at 50. So you hold it for a brief second. Like 5 seconds. We're getting closer. And then if you just do clicks, you do a little bit at a time until you get to 50 milliliters. So again, I'm checking the top right corner to see when I get to 50. And so this is about as precise as you can get, 50.008 milliliters. So I can move this to the side. Now, for some reason, let me just show you what would happen. If for some reason you went over, so let me add a little bit more. Let's say you went over by this much. We added a little bit too much solution. What you can do at this point is you can withdraw some back into the pipette. So we can withdraw down back to, here we get 50.007. So at this stage, if you add too much, you can use the pipette to remove it back down to the volume that you need. At the next stage, you can't do that, but at this stage, you can. So I'm going to move this here. Now we're ready to add it to our volumetric flask. So I'm going to bring the graduated cylinder until I see the green target. And I'm going to pour all of this into the volumetric flask. So notice when you pour in the graduated cylinder, it's a little bit slower than it was with the beaker. So we've added the 50.007 milliliters of solution. Again, you can check in the top right hand corner, it says 50.007. So now we have to add the rest with water. Now you don't have to measure the water, you just have to add it until you reach the calibration mark, and that's the tricky thing. So now I'm going to go get another beaker, and I'm going to fill it with water. And again, you have to be just quick. It's very quick dispense, so I just got about 92 milliliters of water. Let me remove some things. You always want to keep a clean workbench so you don't cross-contaminate. So now we're going to add the water to the beaker. Again, you see here in the insert, we want to get right at this calibration mark. Now here, if you go over, you have to start over because you've messed up the dilution. So it's very important that you don't go over at this point. So again, we're going to add it with the beaker as close to 50 as we can. And then the next what we're going to do is we're going to get a pipette. So right now we have 92.8. And if you try to use the beaker again, you may get lucky. You may go over. So to be cautious, I'm going to go get a 5 ml pipette and get some water to use. Since we have 92, I'm going to fill this all the way up to 5. So I don't have to worry here. I can discharge all of it into the volumetric flask. So now you see the meniscus of the solution is getting close to 100. Our volume in the volumetric flask is 97.82. Take the pipette, get some more water. Now here we have to be careful. We don't want to go over. So we're at 98.42. Now we're at 99 milliliters. This is very important that we don't go over, because then you got to start over. When you get near to the close to the 100 mil mark, if you just do quick taps, it does like 0.02 at a time. Takes a little longer, but you're less likely to go over. And so this is as close to 100 as you can get, 100.002. So now we've made our 50% solution. So if we right click, we can rename this as 50% solution of HClO4. So now you've made the 50% solution. We want to determine the density of the solution. So then we're going to go back to our workbench. Underneath the Glassware button, you'll see an instrument button or tools. We're going to click on that. We want a scale. Now there are different ways to use the balance. You could put the item you want to weigh when it's empty and click the tare button. But I've noticed in the past the tare button is not that accurate. So what I recommend is do weigh by difference. So make sure your balance is set to 0.000. And to do the density, I'm just going to use a 10 milliliter graduated cylinder. So what you do is you take the empty 10 milliliter graduated cylinder, put it on the balance, record the mass of the empty graduated cylinder. So let me write that down here. And remember, all digits in an electronic device are significant. So that's the mass of the empty graduated cylinder. Now what we're going to do is we're going to take it off. And we want to add 10 milliliters to the graduated cylinder. So I'm going to get another beaker. Pour some of my solution into the beaker. We don't need much, just 10. And so you see here in the beaker, I put about 10 milliliters of solution. Now we're going to add that to the graduated cylinder. And so you notice here on the graduated cylinder that I've gone over 10 milliliters. I have 10.663 milliliters. At this point, it's okay because it's all the same solution, so we can go get another pipette. Let me clear up my bench. And we can take some of the solution out. So I'll get another pipette. So again, when you're doing the density, it's okay if you go over. You can always withdraw out at this point. Withdraw solution out. So this is about as close to 10 as you can get. We got 10.013. That's fine. Just make sure you record the actual volume. We're going to be using it to calculate density. So our volume of solution (10.013). We put it on the balance, and now you see the mass of the solution and balance is 37.0119. I mean, solution and graduated cylinder. So the mass of the solution is just the difference between the two. And we get 12.7. So now we have the mass of solution, we have the volume of solution, we can find the density of the solution. And it should be written to 5 significant figures. And now we have the density of the 50% solution. Now at this point, do not throw away your 50% solution just in case you're going to need it later, actually, and also just in case you want to redo it, you have solution left. So now we're going to prepare a 10% solution. So first I'm going to clean off a few items so I don't cross-contaminate. And so to prepare a 10% solution from the 50% solution, we're going to need to use our C1V1 equals C2V2. We're going to prepare 100 milliliters of a 10% solution from a 50% solution. So again, our C1 is 50%. V1 is what we're looking for. C2 is 10%. V2 is 100. So when we set this up, we get V1 equals 20. So we need 20 milliliters of the 50% solution, and then add the rest with water to make a 10% solution of perchloric acid. So again, the glassware I'm going to use, I'm going to remove this balance for now. We're going to need a beaker, 250 ml beaker. We're going to need a graduated cylinder. So here, since we only need 20 mils of the 50% solution, we can use a 25 milliliter graduated cylinder. And we're going to need a 100 ml volumetric flask. So the first thing we want to do is measure 20 milliliters of the 50% solution. So what we're going to do is we're going to take the 50% solution, we're going to add some to a beaker. And now we're going to pour it into the graduated cylinder. At this stage, it's okay if you go over. You can always withdraw some out with a pipette. So we're going to pour. And you see here, I did go slightly over. I have 21.165 milliliters. This is not a problem. If you go over, you just go here, get you a 5 ml pipette. And we're going to withdraw the solution until we get to 20 milliliters. If you look in the top right hand corner, you can see the volume decreasing. So we put 20.005 milliliters. If you put 20.01 or 02, that's fine as well. Now we're going to add this to our volumetric flask. And here you're going to pour all of it into the volumetric flask. So we've added the 20 milliliters of the 50% solution to the volumetric flask. Now we need to add the DI water. So I'm going to remove a few pieces of glassware to clean up my bench. Beaker. So now we've got to add roughly 80 milliliters of water to this. This is where you want to be careful. So we have 69, 88. One more. Whew, 92. On this stage, you don't want to go over because you're going to have to start over. So now I'm going to get a 5 ml pipette, transfer some water from the beaker to the volumetric flask. And we're going to discharge all of the 5 milliliters because we only have 92 in the flask. So now you see we're at 97.176. So we go back, get some more DI water. Now here, this time we have to be careful not to go over the mark on the volumetric flask. And when you do, you'll get the hang of how long you should hold the button to get the right amount of solution. And then when you get close, again, just do quick taps. It does it at 0.02 milliliters at a time. So now we got to 100.005. Again, this is about the closest you're going to get to 100. So now we've made our 10% solution. So let me remove some glassware. We can rename this. So you right click, rename 10%. So now we're ready to measure its density. So we're going to need a balance. And we're going to need a 10 milliliter graduated cylinder. And so the first thing we want to do is measure the mass of the empty graduated cylinder and record that mass. Now we need to add 10 milliliters of our solution to the graduated cylinder. Now again, here, if you go over, you can take some out. If you're a little bit under, you can use that as well, as long as you record the volume that you use. Now, one thing to bear in mind is that since we made a less concentrated solution of the perchloric acid, our density should be less than the 50%. If it's not less than the 50%, we've done something wrong. So I've added some solution to the beaker, and I'm going to pour it into the graduated cylinder. So I went a little bit over, so that's okay. We can just get a pipette. And remove some solution. So we get 10.004. If you look in the top right hand corner, it says 10.004. So that's the volume of solution. Now we put it on the balance. Again, when you see the green target, you can let go of the mouse button. And now we have the mass of solution plus graduated cylinder. Now we can find the mass of solution. $10.5443 grams. And we can determine the density. And we get 1.0546. 1, 2, 3, 4, 5. And that's the density of the 10% solution. And notice how it's less than what we calculated for the 50% solution. And so you would do this process. For the 50% solution, you have to make a 25% from the 50% and a 10% from the 50% solution. And then with the 25% solution, I believe you have to make a 12.5% solution and a 5% solution. And this is the same process, the calculations, the process you'll do for all those solutions. Let me just clean up my lab bench. And I would keep the solutions until you're sure you're happy with the data, and for all the solutions. That way, if you mess up, you can always go back and use your solution.